In the name of God, welcome the fourth episode of learning SAP software. Actually, in this episode, we are going to design and analyze another type of the beam. That this type of the beam is actually called fixed end beam because at the two sides we have actually fixed support. In here, if you see, this is our first span and this is our actually second span. But our second span of our beam is actually rotated around 45 degrees. Top and bottom. It means we should rotate our second span minus 45 degree and plus 45 degree. And UDL load act from start up to end of the beam with amount of 2 turn per meter. So how we can design and analyze this type of the beam? First of all, we have to open our SAP software. Then you know that by 3B we can plot our beam, okay, by blank page, by grade, and also by a specific template of the beam. So in here we can use the specific template of the beam. Make sure with your units. Now number of span is 2. Then here we have span length. If you see here, our total span is 1.2 plus 3 is 4.2. So we can take our total span 4.2 meter. Then in here we can half our restraint now, okay, then okay. Now if you see here and if you see the status bar, okay, in here the value of x should be 4.2 and it is actually 4.2 and the origin is 0, 0, 0. Now what should we do? Now we have to plot a point at a distance of 1.2 meter. Okay, we have to plot a point at a distance of 1.2 meter, and then the rest of the span should be 3 meter. So how we can do this? Just select all of your member. Now in here, if you see, we have only 3 points, one at the start, one at the middle, and one at the end. But we don't need this point. We have to plot the point around the 1.2 meter. So how we can do? So it's also discussing of the previous session. Just select all of your member, then come in a edit line, divide frame. Last first length ratio. In here, actually don't consider the whole length 4.2 meter. You have to just consider 1.2 meter and 3 meter. We gave the value of 4.2 meter or distance of 4.2 meter because of the simplicity of our works. So now in here, how we can take the distance? Just come here, 1.2 divided by 3, 0.4. Here we have to write 0.4. Then apply and then OK. Now if you see at the distance of 1.2 meter, if you see this status bar, at distance of 1.2 meter we have point. Now we have to plot the our restraints or our supports. So how we can do? Just click this side and click this side, come to an assign join restraint, select the fixed support, apply and OK. Now if you see in the picture, this fixed support is not 0 degree with the ground surface, it's actually 90 degrees. So we have to rotate our restraint. So how we can rotate our restraint? Just select this restraint, come in assign join local axis. In here around y axis we have to rotate 90 degrees, then apply and then OK. Then we have to rotate this span 45 degree and minus 45 degree. So how we can do this? You have to select your member. Okay, now if you see, this member is actually 1.2 meter and up to here is 3 meter, but it is actually extra member, so we can delete this. Okay, now in here we can plot the restraint. Now we have to rotate this. So how we can rotate this? You have to select this point, this member, okay, then come in a edit, replicate. We can do or we can copy our member by 3 methods: linear, radial and mirror. Now we are going to talk about radial. You have to rotate it around the y-axis, okay, 145 degree upper and 145 degree inner bottom. Then pick one point around this point, rotate, okay, then apply and then okay. Then also again we have to do for top. So come in a edit, replicate, radial around y-axis. In here now minus 45 degree, and also delete the original object like this. Now if you see, it is actually same with the picture. Actually, if you see, it's actually same with the picture, but in here also we have to rotate our fixed support. How? If you see this fixed support, we should rotate 45 degree, because if this angle is 45, so this is also 45 degree, but we have to get minus 45 degree. And about top support, how we can rotate this support? Just if you see, this is actually 180 degree, and this is also you have 45 degree, so 180 plus 45 degree, it become 225. Now this fixed support we should rotate 225, and here we should rotate minus 45 degree. So just click this, come in assign, join, then we have local axis. In here we have to rotate minus 45 degree, apply and OK, and here we have to rotate 225 degree. Apply and OK. Now if you see the picture, we finish with modelization step. Then we have to go in and define material. Which type of material? It's actually made up of the concrete, we can see that. So come in and modify show material. In here you can change the unit in the kilogram meter. Then is at 2400 the density of the concrete. Okay, and everything is okay. Now in here the compressive strength we can get 3200, and also expected we can get 3300. Then okay, then we have to plot the steel or rebar. So just come here and modify show material. This is actually 7850, and all thing is okay. Then okay. Then we have section property, frame section. We have actually beam, so add new property. Come in a concrete rectangular. We can get some dimension of the beam, for example 0.25 to 0.20. Okay, then concrete reinforcement. Here we have beam, it should be 0.025, and here also 0.025. If you don't know the concept of this thing, you should watch the second episode of learning SAP software. Okay, and then also okay. Now we can also change the name beam. Then we have the load pattern. We have one dead load, then we have one live load. Third we have live, add new load pattern. Okay. Then also we have load combination. If you design according to ASD, allowable stress design, you don't have any combination. But if you want to design according to LRFD, you have 1.2 of dead load plus 1.6 of live load. It's in the new version. According to AISC, American Institute is still construction. But if you go or if you want to follow the old version, this combination is 1.4 of dead load, 1.4 of dead load plus 1.7 of live load. So in here we can get we follow the new version, 1.2 of the dead load, then 1.4 of the live load. Okay. Then all of them is finished. Then we have to also assign our beam, frame section. We are in beam. Then we have to apply the load. Come in assign frame load, distributed. In here select the live load. In here also come in absolute and 2 ton per meter. You have to take. Apply and okay. Then what we have to do, then we have to come in analyze, and analyze option, exit plane, okay. Then come in a run analyze, do not run according to model, run now. then save. Now it is actually deformed shape of actually our beam. If you see, it will deform like this. Now then we have to come in a concrete, select design combo, add this combo, and start design check of the structure. Here we can change the unit into centimeter, turn centimeter. Now if you see this member is actually failed. So what should we do for passing of this member? We have to increase the sections. How we can do this? Come here, just come in a define section property, frame section, in a beam, modify show. In here we can take actually 35 to 30, and concrete reinforcement 3 point, because in a centimeter. Okay, if you see this unit, and here also 3.5, then okay, and then okay. Then we have to assign. Okay, then what we have the load. Okay, we don't need to add again the load. If you see, we have the load. Then we have to just analyze it, and then we have to go for design. It's again fill. It means that you have to increase again the section. So it is the procedure that how we can copy, or how we can rotate our fixed support, and how we can rotate our member. So have a nice time. Goodbye.